So we're here to talk about deploying AI models in the edge in the world's largest cloud conference. So that's going to be fun. I'm going to start off with a question that I want some of you all to guess. Every time you take a picture on a smartphone, does anybody want to guess how many AI models runs while you take that picture? Someone said 10. Okay. Anybody else? You said 4? 40. Okay. Anybody else? Okay, good. There's only one wrong answer, which was 0. Nobody gave that answer. But it's in the 20 to 30 range. So there's a significant number of models that run in that. And so both of you are not too far off. There are a significant number of models that runs on a device every time you take a picture. An average smartphone has about 1,000 or so models that are on there. And we have over 100,000 applications in a smartphone app store that uses AI. But it's not just phones. You also have it all over the place with cars. So pretty much all of your ADAS systems are running on-device AI. Smart parking assist, any kind of blind spot assistance. Those kinds of things all use sensors and AI on the device. You also have drones, you have robots, and you have PCs as well. A lot of your PC applications end up using AI on device. So, the obvious question is, why do it on the device when you have access to a cloud with virtually unlimited compute? Why do it on the device, right? And the primary reason I've seen people do it is for this overall snappiness of the experience. So certain things just can't be done by sending information to the cloud and back. And it's much snappier, much quicker, much more efficient to do it on the device. And over the years, as the device packed more and more compute, you can do more and more sophisticated things on those devices. So latency is a big reason why people do it. There's another one, which is cost. I was just recently talking to a gaming company who said they had like a 9-figure bill for doing AI on the devices. Well, it turns out you have gaming consoles that have virtually, probably tens of flops that are available there for you to use. And you can do pretty sophisticated things on it. So you can offload the cost to the consumer's devices. So cost is also a big thing. And there's also privacy, which is a big factor where you have everything that stays in the device. No, everything that happens on the device stays on the device, as the very saying goes. So that privacy is also a big reason why people do this. So today we're going to talk about how you can get some of your applications that do AI on the device. And for the largest time, what we saw was developers found it pretty challenging to take models that were trained in clouds and get them running on various different devices that have different architectures in them and get the best out of the device. So this process was pretty onerous. And over the last 3 to 5 years, we at Qualcomm, we've streamlined that entire process so you can train your models in the cloud. And we've built a ton of automation systems that you can leverage today completely for free. You point your models at the automation, and you can then get a model that you can deploy on the device. And we've streamlined this so that it takes just a few minutes for you to get something compatible for the device and something you can run on the device. So today we're going to walk you through that process, where we're going to showcase what it's like to build and deploy a custom AI application on a bunch of devices. Obviously, the training process is you do it in the cloud. Many of you are familiar with SageMaker. We're not going to go too deep into that, but the idea is you can use your existing training tools as is. You don't need to do anything sophisticated or different. And then you get to the stage where you take the model that was trained in the cloud and you optimize it for the device. Again, that uses a system that we provide free of cost to all our developers. It's called Qualcomm AI Hub. And then once you've have an optimized model, we have another system that is available for you called Edge Impulse, which allows you to take those models and create these kind of deployment pipelines that you can use to deploy on real devices using other AWS services like Greengrass, IoT Core, Bedrock, and so on. And we'll walk you through that entire journey of training the model from the cloud to deploying live on the fleets. And this is, roughly speaking, the architecture diagram. There's a lot of stuff going on there. We'll go over that step by step, starting with the 7 steps that are in the bottom listed out for you. There's the train, optimize, prepare, deploy, run, and monitor. It's technically 6 steps. So we'll go over each of these steps involving different services that all seamlessly plug with each other. And the nice thing is that you can do most of these steps without needing a complicated device sitting on your desk, because there are lots of device farms that abstract away the complications of having these devices. We make them available to you through the cloud as well. So you can do all your development and testing through your normal work environments and then finally see the results live. Okay, so the first step is training your model. You can use SageMaker or pretty much any training service that you use, whether it's AWS provided or not. You can train models with in these environments. You have enterprise security. You can bring your own data. You can manage training jobs. And what's nice about this is that once you're done with the training process, you can get an output, which is an Onyx model or a PyTorch model, which is pretty standard open source format that is completely compatible with the on-device stack. So really the connection between what you do in the cloud and what you do on the edge is the Onyx model format or the PyTorch model format, whatever you're comfortable with. So let's say in the first step, you're going through a training process. And today we're actually going through an application that involves cameras in a factory, which you'll hear more about from our second speaker, where we have defect detection. So let's say you're training a model, you use SageMaker, you collect some data for determining defects, and then for doing whatever you need to do. You train that model, and you're good to go. And then you go to our service, which is called Qualcomm AI Hub. As I mentioned, it's something freely available. And what it is basically a fully automatable service, which lets you to point, which allows you to point at a trained model, and then you pick a device, depending on what device you're deploying to. So it could be a mobile application, or it could be an IoT application, which is what we're going to show you right now, or it could be something in an automotive application as well. And once you pick that device and you say, okay, I'm deploying this model on this device, the edge AI, typically there are many different runtimes people use to deploy the model on the actual device. So some people use TensorFlow, some people use Onyx runtime, there's Executorch, there's also the Qualcomm AI stack if you want to do something super native. So you can just pick your runtime and say, hey, here's the model that I've trained, this is the device that I care about, this is the runtime that I care about, now go, right? And then what happens is we'll optimize the model for that particular configuration, we'll do all the conversion that's needed, all the optimization that's needed, and at the end of it, you'll get an output that you can be sure will run on the device. And the reason you can be sure is because as part of this service, what we offer is a cloud of devices that are plugged in to our cloud, and we'll do a simulation on those physical devices so that we can tell you exactly how fast it's going to run, how much memory it's going to consume, and any kind of accuracy issues if you hit. We also can check that for you. So everything that you typically need to do to take a model that's trained in one environment, like the cloud, and deploy in a different environment, which is the edge, we do all of that in an automation. So it should take you just a few minutes to go and do that. And with that, I'm going to introduce our next speaker who'll walk you through the process of, now that you have a trained model, how do you actually go deploy it on an edge device and make sure you can run and deploy in a live environment. So we'll walk you through that briefly.
Perfect. And before I move on to step 3, I'll just briefly introduce myself. So I'm Ashvin, and I'm a solutions engineer at Edge Impulse. And Edge Impulse was, we joined forces with Qualcomm earlier this year, so I'm actually a Qualcomm engineer now. And I've been in the semiconductor industry for over 10 years, based in Austin, Texas. And what I do day to day is I help our real-world customers build real-world edge AI applications. So that's what I want to show today, how to build this real-world edge AI application that's capable of running in real time and really fast on any type of edge device. And the edge device that we're focusing on today is a Qualcomm processor. So let me jump into step 3, which is preparing the deployment in Edge Impulse. So right now, what you heard from Krishna was you trained a model in SageMaker, right? You have a hardware optimized model through Qualcomm AI Hub. And now what you want to do is you want to bring that model into Edge Impulse. And what is Edge Impulse? Edge Impulse is a platform that allows you to build real-world applications. It can be developers, it can be enterprises, it can be any type of data. In our case, we're going to show computer vision, and you can deploy it onto CPUs, GPUs, MCUs as well. But let me jump in and show you one of our features that we have in Edge Impulse called BYOM, which stands for Bring Your Own Model. So what we do is we take the model file, it can be the Onyx file or TF Lite, as Krishna was mentioning, and we bring it into our platform. And what this allows us to do is you bring in your model, and now you can actually develop and generate an EdgeML package. So we walk you through the pipeline, we get you a model that's hardware optimized. It doesn't require you to have any type of dependencies. You don't have to worry about Python dependency hell. It's fully kind of self-contained, so you can really bring it into your hardware and be confident that it's going to run fully sufficiently and hardware optimized. And our platform lets you it steps you through the process. So it shows you, it lets you choose what output formats. It lets you bring in some sample data so you can eye check and make sure that your model passes the eye test. And once you're happy with the model, you can do, which is on the right side, which is deploy. So we have a wide array of what you can deploy on, and because our device is the 6490, a Qualcomm processor, we can choose that easily in our UI. So once you have the actual model, the next step is to deploy the model. So you've generated your model file. Now, how do you get it onto your fleet of devices, right? So the use case that we've been talking about is pill defect detection. So imagine you have a whole factory floor or multiple factory floors that all have conveyor belts, and there are pills going down the conveyor belt, and you want to go and put your model onto each one of these devices. Now, you could individually go and update the firmware of all of these models, right? And individually go update the model. But obviously, that's time consuming, and that's also very expensive. So what we can utilize is AWS IoT Greengrass, which allows you to deploy onto your entire fleet of devices. So it requires 3 steps. And for those of y'all who are familiar with IoT Greengrass, you might see these images and resonate with them. But the first step is you actually install Greengrass on your edge device. And because we're using a Qualcomm processor, it's running Linux OS. In our case, Qualcomm Linux, it's actually really easy to install Greengrass. It's just a couple of dependencies that you have to install. And we have instructions online for all of this. So feel free to ask me, and I can point you in the right direction. And one note, even if you're using another OS like Ubuntu, it's exactly the same steps as well. So we really allow you to choose whatever you want to use. And then the next step is customizing your YAML recipes. And what is this, and why are we doing this? Well, what are we trying to deploy, right? Like we want to deploy something that will allow us to get the model and also test the model on our edge device. And Edge Impulse helps you do that with a software tool called Edge Impulse Linux Runner. So what the YAML recipe is setting up is setting how to get this Edge Impulse Linux Runner on all of your devices. And once you set that up, you create the component, you put it in an S3 bucket, and the final step is actually deploying it on your device. And something that I was very pleasantly surprised about with using AWS is all of these steps that you see right here were done through the management console. So when I was setting up the demo, and for those of y'all who stopped by the Qualcomm booth, you might have seen this pill defect detection running live. All of these steps, the Greengrass steps, were all set up in the AWS management console. And it's super intuitive, super easy, and you don't actually have to run some complicated scripts locally just to get up and running. Okay, so now we've talked about generating the model, and now we've talked about deploying the model. Now the next step is actually running the model that is actually on your device. So why do we want to do this? Well, in our use case, we don't want to just, you want to be able to do something with your models, right? You want to have him do some action. So what we want to do here is run the Edge Impulse Linux Runner, which I talked about in the previous slide. And what this allows you to do is essentially get two types of outputs, and it really depends on what you're trying to do at a moment in time. So one of the types of output is just simple text bounding box inference in our use case, because we're trying to see where the pills are, right? So you can see the bounding boxes where the normal pills are and where the bounding boxes where the defects are. And that eventually we will send up to the cloud for further monitoring and analysis. But before I jump to that part, I also wanted to quickly note that the Linux runner also lets you visualize all of your inference results, right? So on the bottom right, what you just saw was just local processing, right? So you're not actually taking images, having the video stream, and sending it up to the cloud. What you're actually doing is running the model on the edge locally. And if I kind of go back and play this animation again, you'll see just how fast this model is running, right? So this is honestly not just a nice to have in a manufacturing use case that we have, but it's a necessity to be able to have a model that's running so fast. And when you have some crucial aspects, let's say like you have a large defect trend, you want to be able to stop your assembly line and have a technician go check it out. So it's really important to not always send all your images up to the cloud at some point. All right, so now we've discussed training the model, we've discussed deploying the model, and now running the model. And now the next step, and almost pretty much the final step, is actually doing something with this data. So you're monitoring, you're analyzing, and for any of the AWS experts out in the audience, once you get it onto some AWS component, you can really do anything with it, right? So in our case, what we did was we sent the data, pretty much the inference results in text format, to AWS IoT Core. And once it was in IoT Core, we were able to publish it, add it into a time stream database, and then from there, we showed a Grafana dashboard that was querying from this database, and that's what we showed at the booth for anyone who stopped by. But what this is really there to show is it's up to you, it's up to the use case, and it's up to the customer to decide what they want to be able to do. So in our use case, we're trying to find defects, right? How many there are, where they are, and is it trending in the right direction or wrong direction? So by seeing the graphic on the bottom right, you're seeing that we're having a decrease in the defect rate. All right, so we've gone through all of the steps, right? So we started with the training, we went to optimizing, we prepared the model on Edge Impulse, we deployed and ran it using Greengrass, and now we're also monitoring. So with that, we've completed the pipeline from kind of start to finish. And let me just kind of go through a couple of the the learnings that we found. So one is we reduced the training time by using Amazon SageMaker. And as Krishna mentioned, by using SageMaker, you can train your model. In our case, it was computer vision. And also going from SageMaker to Qualcomm AI Hub, we were able to achieve 20 times faster throughput by optimizing the model. So the whole point of AI Hub was to optimize your model for your specific hardware. And also with AI Hub and then Edge Impulse, we're also able to create a model that was so efficient that it had just a few milliseconds of latency. So the inference speed was really fast, and we were able to see it in the graphic in the last slide where you see the pills being detected for defects in real time. And then finally, thanks to the integration of Greengrass and Edge Impulse, we were able to deploy the entire fleet of devices that you have set up in AWS with your models. And for final takeaways, which what I want to leave you with is kind of just what is the flow? What do we actually see today? One was, obviously, we started with SageMaker. That really speeds up your development time, and we have examples for all of this on our websites, and I'll send you some links and QR codes shortly, so you can check out how to get set up with your own use case. We took the model, we had AI Hub really optimize the model, we had Edge Impulse take that model, put it into a more easily deployable artifact that the Edge Impulse Linux runner was able to deploy onto multiple devices using Greengrass. And with that, you can see how we really use the best of both worlds, right? We used Qualcomm technologies to show that we have Qualcomm AI Hub, we have Edge Impulse to really optimize your model, and get it something that's really edge optimized so you can run it really fast. And then we also use AWS technologies to take advantage of their cloud infrastructure to get the model out into the real world, and then not just get the model out there, but also start monitoring and analyzing and doing some real world use cases with it. So with that concludes our presentations, and here are the QR codes that I promised. So if you want to get up and ready with Edge Impulse, there's our landing page for a free sign up that you can go and test out. And one other thing to note is right now, what Krishna and I talked about was a computer vision use case, right? But let's say you have another use case, you've got some like audio-based use case or motion-based use case. What you can do is upload whatever data set that you have or your customer has into our portal. We'll train a model, similarly what I showed you for computer vision, but for the other data sets, and we can kind of walk you through the whole pipeline just like I showed. And then similarly, we have the landing page for Qualcomm AI Hub as well. So yeah, with that, that concludes our presentation. Thank you.